Okay, guys, I'm probably going to be out tomorrow or today because of family issues. Some stuff happened. So we're going to be taking a look at our arithmetic sequences, and they're just number sequences and seeing how we get that. And what's important here is to understand inside of an arithmetic sequence is that we have a sequence of numbers and it has certain rules to it. And if it's arithmetic, we have something called an add-add rule. So we're going to get something called a common difference. That's important. We take two numbers and we just subtract them. We just take one number and then subtract it from another number. And it's going to be in a special order. So you're going to see this right now. It's always going to be the second minus the first. Okay, this thing is not behaving today. Okay, so we have an arithmetic sequence. So x represents the placeholder, where it is in the sequence. You have the 0 term, and then we have the 1 term, 2 term, 3 term, 4 term. And each one of these has a number associated. Like right here, if you take a look at this, this has 3, then 5, then 7, 9, so on and so forth. Now, to get the common difference, we're going to take these two numbers, and it's always the second number minus the first number. So that gives us a 2. Then you go to the next two, including the 5. So 5 is going to be the next number, and 7 is going to be the one after that. So we take 7 minus 5, and their common difference is 2 also. This thing is not working very well today. Then you do the same thing for the next two. 9 minus 7, that also gives us 2. Then finally we have 11 minus 9. Well, that gives us a common difference of 2. Now, if you see right here, this is what they mean by common difference. Common difference is if you took the sequence and subtracted the numbers, is the common number that you have in between them. So right here, the common difference is 2. So each time, they're adding 2. So if you want to get the next number in the sequence, which would be placeholder 5, this would be 11 plus 2, which would be 13, and then 15, and then 17, and so on and so forth. And that's basically it on that. Okay, so wants us to find the common difference. You know how to do it. All you do is take the first two numbers, subtract them, 11 minus 7, and that gives us a common difference of, let me see, 4. You do the same thing here, just to go ahead and see this, just to check. 15 minus 11, that's also going to be 4. So our common difference is 4. So common difference is equal to 4. And we're going to use this to build a sequence. And we're going to build both something called explicit and recursive sequences. Now this one's a little bit more difficult. Now right here, we don't know what the number is right here or right here, but we can at least take the common difference between these two numbers. So let's see, this is going to be 12 minus 7, which gives us 5. And since we're looking for the number in between and it's going to be equally spaced, then we just need to divide that by 2 because it's like the average between those two. So it's going to be divided by 2. Which is going to give me 2.5. So our common difference right here is 2.5, and we can actually double check that. So that's going to be 17 minus 12, which gives us also 5. We're going to take 5 divided by 2, which gives us a positive 2.5. So our common difference is 2.5. Now, this is the recursive sequence. Now, the way this works is that we have this sequence right here. It's a of n. Let me go ahead and do this real quick. I'm going to go ahead and bring this up. Let's see. I'm going to go back up. I'm going to copy a sequence right here. I'm going to copy this one since we haven't done this one yet. I'm going to go ahead and put that to my clipboard. I'm going to bring this back over here. Okay, now, let me just go ahead and go through this right here. Eighth of n just represents our place in the sequence. A1 represents the first number in the sequence. We got to know what we start with. So that's going to be 12. Now we're going to add, and D stands for the common difference. It's going to be our common difference. So we need to find the common difference. So 12 minus 1. So 1 minus 12 gives us negative 11. Just checking if this will also give us negative 11. So it's going to be negative 10 minus 1. You notice I'm keeping the exact numbers here, and we do get negative numbers, so it's minus 11 also. And this one also, let's just go ahead and do this as a check. So negative 21 minus negative 10. Whoops, bounces. So negative 10 to negative gives us a positive, so that's going to be negative 11. So our difference is going to be 11. So then instead of plus D, it's going to be minus 11 times n minus 1. And that's it. That is our explicit form. So this is explicit. This will give us any term. All we need to do is plug in, and then it'll go ahead and shoot out a number. Recursive is a little bit different. This states that we're going to be working with our terms. So this is explicit. This is an explicit function. Explicit. Now recursive is a little bit different. So this is explicit. Recursive is a little bit different. Now, also what negative 11 represents is also the slope. So, right here, when we want, let me see. Well, no, I forgot. I'm doing recursive. Okay. So, so this is a recursive algorithm for arithmetic sequences. A of n is equal to A of n minus 1 plus or minus plus whatever D is. And that's it. Oh, and we have to state a few things. Where? And we have to state where we started. A sub 1 is equal to 12. So that's what we have to do here for a true recursive sequence. This is the other one's explicit. This is recursive. And that's all you're supposed to do for that. And so let me see. All you're going to do is put A, and all you have to do is write A sub n is equal to A sub n minus 1 minus 11, where A sub 1 is equal to 12. Oh, and I forgot one little thing. Where n is the sequence of numbers of, instead of starting this with 1, because we already have 1 done, we're going to start this with 2, 3, 4, 5, dot, dot, dot. Close that. And that's basically our domain. We're just writing down the domain. What's n going to be equal to? Okay. And that's about it. I mean, that's it. So if I were to write this into an explicit sequence first, actually, let's go to the first one here. Wow, this thing is not wanting to behave. There we go. So our A sub 1 is 7. Our D is 4, and all we have to do is write the explicit function. So A sub n is equal to, let's see, let me do this again. Let's see, A sub 1 is 7 plus 4 times n minus 1. Where n is equal to 1, 2, 3, 4, whatever. Okay, so that's the explicit function. Now, we want the other one, so let's see. So that's the explicit. We want the recursive. So recursively, that's going to be a sub n is equal to a sub n minus 1 plus 4, where a sub 1 is equal to 7 and n is, and we're just going to write this, and it's going to start at 2, 3, 4, dot, dot, dot. These parts are the ones that are going to be always the same. The only thing that you have to write differently for each one of these, I'll go ahead and do this, is this part. That's it. And that's pretty much it. If you have any questions, please email me. I'll be right here. If I'm going to take off, I'm not going to be here. I have to take care of my son and my daughter, so it's going to be all that. All right, guys, I'll talk to you guys later.